My name is Joel. I designed the current WLAN Pi case, so just going to talk about it really quick. So as with any Wi-Fi project, we always start with a set of requirements. And so one thing we wanted to do is take the WLAN Pi and turn it, instead of being like a kit, something you have to take out of your bag, plug a whole bunch of stuff into, we wanted to make it something that was a tool that you could just chuck in your bag when you're done, pull out when you're ready to use it, and not have to assemble things all the time. So we designed it around a specific set of requirements. First off, we wanted it to contain a Wi-Fi adapter. So there is a Wi-Fi adapter concealed inside this case. We also wanted easy access to USB and Ethernet on the bottom. I think the Ethernet port is one of the most important things about the WLAN Pi, so we didn't want to block that. Things like throughput testing, we need access to that. We also wanted to have it hold a USB-C cable. This was Keith's idea. You always lose the cable, so why not just leave it attached to the case? And then we also include a little USB-C to USB-A adapter, so if you still have USB-A, no problem. You have everything that you need right there. Now, the fourth one is a little bit less intuitive, but we needed it to be easy to 3D print. A lot of this case is designed very specifically to be very, very easy to 3D print and mass produce on a 3D printer, which turns out is a really terrible way to mass produce things, and we'll talk about that. So here are some of the prototypes. Started out with the orange one is just like a block to make sure that I had all the dimensions and everything right. A really, really important tool that if you want to start 3D modeling is you need to buy a set of digital calipers. These are like $6 and I use them constantly. This is my most used tool in my house is my $6 pair of digital calipers, but you can see all of the different iterations that this thing went through before it got to where it is today. So here's what the inside looks like. You can see that there is space for the Wi-Fi adapter. It sandwiches the USB micro to USB-C cable in there so it can't move around or anything like that. And yes, there is a little potato inside every single WLAN Pi case. Quick show of hands, who has a WLAN Pi in a case right now? Cool, awesome. Yes, there is a little potato in there. So just wanted you to know that it is there. So here's what it looks like from the other side. You can see where the micro USB cable plugs in there. And here's what it looks like from the top. Now, one thing that we did is we are printing this on the 3D printers that we're using to produce these is the Prusa i3 MK3S Mark III's. One thing I really like about this printer is that it has a textured bed. And so the bed is a powder-coated Ultem, I think I got an Ultem coating or something like that on it, and that gives us this really, really nice textured finish on the front. That's how we get that textured finish on that. On the back, you can get to the SD card slot. We still can't quite do over-the-air firmware updates on the WLAN Pi, so you have to remove that for now. So we have a way for you to get that out. And there's a little tray that the card sits in there, so you can line it up and use your thumb to push in there and click it into place really nicely. And also, there is a little spot where, see if I can zoom in on it there. There's a little spot where you can see the power LED. So when you first plug it into your laptop or a power source and the screen hasn't come on yet, you can quickly flip it around and look at that and see if you have power or not. So a little bit about the production of it. This is, for a long time, this is how I was producing them. We would print three backs, and then on the other printer I'd print 3 fronts, so I had 2 printers running, one just doing fronts, one just doing backs. On the fronts, I squished the plastic down into the bed a little bit more to get that nice, even front. On the back, though, you see how it's printed with the inside facing down. That didn't matter as much, and so we printed them a little bit higher to compensate for that. So we needed a bunch of these for WLPC in Europe, and I had about 10 days to print 75 cases. And we really, really had to have these cases for deep dives. So with 2 printers, we do 3 backs on one, 3 fronts on the other, and it took about 8 hours to print 3 complete cases. So I would start prints at 8 a.m., about 4 p.m., and about midnight, which gave us a yield of 9 cases every 24 hours. And so that gave us about 63 cases per week. Of all that, I only had about 6 cases fail, which is a really, really good rate for a 3D printer. Very, very appreciative of my wife, who put up to listening to 3D printers running 24 hours a day. And my office is directly above our bedroom, so 3 a.m., yeah. And when I was traveling for work, when I was gone teaching ECSEs or whatever, she was running the printers, and so she printed a lot of those. This time we were able to prepare a little bit more, and that was nice. At this point, just a few minutes ago, I delivered the 400th case to Keith. So there are 400 of these in the wild. So the case that you have now is a little bit different than these are the ones that went to WLPC. A little piece of trivia that I think is funny. The Prusa Mark 3S, the kits are made in Prague. And so I bought those kits from Prague, built the 3D printers, and then bought filament from Prusa, from Prague, brought them over here to Idaho, or over to the United States to Idaho, printed out a ton of these cases, and then put them all back in a suitcase and flew them back to Prague. So I thought that was kind of funny. Very roundabout way of doing things. Now, one thing I didn't like about the original design is that the screws went through the front of the case, and that's kind of problematic from two standpoints. First off, when you put the sticker on the front, you can't get inside your case anymore. And if you don't align the SD card just right, you can lose it inside the WLAN Pi. Now you have to peel up your sticker, and it's just not great. And the other thing too is that first layer, you want to keep the first layer of a print as simple as possible. Any additional complexity in that first layer just ever so slightly increases the odds that that first layer might not stick quite right and that you might have to restart the print. We don't want to do that. So I redesigned it with no holes in the front. So now the screws go through from the back and they get captured inside the front of the case. That's just a little thing that we did. So I thought you might want to see where the printers come from. So this is my little print farm in the corner of my office. So right now I've got 3 Mark 3S's running over there. And so they just sit there and crank out cases whenever I'm home. Gene, you're somewhere in the room. My boss, Gene, somewhere in here. Whenever he calls me, I'm sure he's sick of hearing because you know the printers are always running when I'm at home. I do have to kind of plan when I'm going to print around calls and things like that. So a little closer look, and oh shoot, I did not mean to show this. Don't look at that. Stop. Oh, dang it. Didn't mean to show that. Okay, well, I guess the cat's out of the bag. So this is kind of what's coming next. This is the WLAN Pi sensor version. So this is oh, thank you. So if you can't already tell what's going on here, this has got a PoE, what do you call it, dejector on it. Basically a PoE splitter on it, so it's PoE powered. Here's what it looks like from the back. Still working out all the final things on this design. It's definitely a work in progress, but it's coming along. It's looking really nice. Here's what everything looks like inside. The size of the case is definitely dictated by how far things stick out of the WLAN Pi. That's very, very tricky to design around. You just have to keep it a certain size to make all that work. So that's kind of what's coming. So really quick, before I wrap things up, I just kind of want to show you what the process for designing this looked like. So I use a tool called Trimble SketchUp to do my design, and I'm here to tell you, do not use SketchUp. Do not use this tool. Because let's say that we want to just make a little change here somewhere. So I'm just going to select this, and I'm just going to move this up in a way to kind of get it out of the way here. And let's say that we just want to, like, I don't know, bump like this face back a couple millimeters. So if I grab it, and then maybe we'll like move it really quick, and oh my gosh, what just happened? And what's awful is that sometimes I'll make little changes like that and not realize that I just affected something on the opposite side of the part, and I've ruined my whole model, and now I've got like an hour or two of backtracking to figure this out. SketchUp is a surface modeler. It is not a parametric modeler. A proper parametric modeling tool allows you to define parameters for things. Robert, are you in the room? Boardman? What tool should I have used?
Fusion 360.
All right. I just wanted to give you the opportunity. I knew you'd love that. So yes, learn Fusion 360. That's on my list of things to do, is to not use SketchUp anymore. So really quickly in the last little bit here, let's just go ahead and prepare a part. So I'm going to select that part, go to File, Export STL. An STL is a stereolithography file. It's kind of the standard for what we use for 3D printing, so I'll save that really quick. Now I'm going to open up my slicing tool called Prusa Slicer. Slicer takes the 3D model and turns it into G-code, which is basically a gigantic text file of coordinates that the printer just blindly follows. So this is where all the math for that happens. So we'll grab our STL and drop it in there. So there's our STL, and I'm going to flip it over and print it on its on the inside like that. And so then we'll, let's say that we're going to do 15% infill. That's what I do these at. We're going to do this at 0.2 millimeter layer height. So every layer is 0.2 millimeters high. That's kind of the middle ground. It's a nice balance of speed and looking good. And then we'll go ahead and let's add support material. So we'll do support on the build plate only. And yes, and then hit slice now. And now it turns that part into G-code. And so now we can actually see the insides of the part, and we can see what everything looks like. At that point, I drop this file on an SD card, I plug it into the 3D printer, and I hit print on the printer, and off it goes. One quick last little detail before we wrap up here is I like to monitor my prints remotely. I'll start a print and then leave, to go shopping or something like that. And so I have a little, I have a webcam on a Raspberry Pi on the 3D printer. Obviously there's some things that are not 3D printed there, but I staged that. But this is live at my house right now. Clearly I'm not printing stuff. But that's just so I can keep an eye on things while I'm gone, and if there's a horrible failure, then I can rush home and turn off the printer before it damages itself. So, okay, that's it. Thank you so much.